Okay, so when we go to solve an equation with an absolute value, what we're going to do is rewrite things so that instead of writing our two solutions compactly with this absolute value, we're going to just expand what those two solutions are. So for example, here when we say absolute value of x equals 1, well, there are two ways there are a couple of ways of solving this. So if we go up to our graph and think about it, we want to know when is our output equal to 1. And if we look across, we'll see that there are actually two values at 1 and at -1. So we could say x equals 1 or x equals -1. If we think of it in terms of distance, this is saying our solutions are x that are distance 1 from 0. Okay, so if we start off at 0 and we move one step to the right, that takes us to 1. If we move one step to the left, that takes us to -1. And so these are our two solutions. Okay, those were the two possibilities. Either we move to the right or to the left. Okay. All right. Okay, if we look at an example like absolute value of 2x minus 5 equals 3, the idea that we're going to use is that we expect, as long as our right-hand side is positive, we're going to expect to see two solutions. Either the inside of the absolute value is equal to this outside value 3 or -3. Okay, so we're going to take this whole inside, 2x minus 5. There are two ways that we could be equal to 3. Either that 2x minus 5 is actually equal to 3, or it's equal to -3. If it was equal to -3, when we take the absolute value, we strip off that negative sign, and so our absolute value is 3. All right, and so what we're doing here, we're taking our inside, and we're going to set it to be equal to 3 or -3. So the two ways that we can make this happen. And then we're going to solve each of these resulting equations. So we find 2x equals 8, and so x equals 4, or we find 2x equals 2, and so x equals 1. And so these are the two solutions. If we wanted to think about this graphically, we could look at the function absolute value of x and think about rewriting absolute value of 2x minus 5 in terms of compositions. So this is absolute value of 2 times x minus 5 halves. So going back to transformations of graphs, we're going to take the graph of y equals x, y equals absolute value of x rather. This factor of 2 means we're going to means that we are going to compress horizontally by a factor of 2. So that gets us to something like this. And then we're going to shift right by 5 halves. Okay. So we have something like this, and then we could set our y value equal to 3 and look for our solutions. So we could add in y equals 3 and look for solutions. All right. So this is just a sketchy sort of picture of what we would do. We would probably want some graph paper if we wanted to do it graphically this way. But we definitely can clearly see that we're going to see two solutions from this. Our basic steps when we're solving an equation, so that means there's an equal sign with absolute values, is that we're going to get our absolute value all on its own. We're going to expand our absolute value equation from x equals a, absolute value of x equals a, to x equals a and x equals negative a. This should say or x equals negative a, and then solve. So that's really what we were doing here. Was we had this already isolated and we expanded it into these two equations. So the two mean the same thing, just writing it out more fully. And we did the same sort of thing here. We started out with this absolute value isolated, and we expanded it into two equations here. And then we solved. Okay. Next, we'll look at solving inequalities with absolute values.